in a milestone that has captivated the global scientific community and tech leaders alike. Researchers have successfully uploaded the complete brain of a fruit fly into a computer, effectively creating a digital living entity. Unlike traditional artificial intelligence models that rely on massive datasets and statistical training to mimic human language or logic, this breakthrough represents a raw digital copy of biological neurons and synapses. Using advanced electron microscopy, a Silicon Valley startup mapped every single one of the 125,000 neurons and 50 million synaptic connections within the insect's brain. This digital blueprint was then integrated into a virtual body within a simulated physical environment. Without any pre-programmed instructions or training data, the digital fruit fly began to walk, groom itself, and search for food, proving that complex behavior is hardwired into the physical structure of the brain itself. The behavior of this virtual insect reached an accuracy rate of 91% compared to its biological counterpart. While modern artificial intelligence systems like large language models are built by adjusting billions of parameters to predict the next word in a sequence, they lack a true understanding of their own existence. In contrast, this experiment followed the opposite path by focusing on physical structure. By replicating the architecture of the brain and providing a simple activation model, intelligence emerged naturally from the connection map. The system relied on only 4 primary elements: the connection map of neurons, the weights determined by the number of synapses, the classification of excitatory and inhibitory neurons, and a basic activation model. The implications of this achievement are profound. Although the human brain contains 86 billion neurons, which is roughly 600,000 times more complex than that of a fruit fly, experts suggest that scaling this technology is an engineering challenge rather than a scientific mystery. The primary obstacles are the time and computing power required for high-resolution scanning and data processing. While training a modern artificial intelligence model can cost hundreds of millions of dollars, this startup achieved these results with a fraction of that funding, totaling approximately $3.5 million. Their next goal is to map the brain of a mouse, which contains 70 million neurons, before eventually attempting to digitize a human brain. Despite the excitement, the experiment faces certain limitations. The fruit fly's physical body was not scanned as precisely as the brain, requiring researchers to estimate the connections to the motor neurons. However, the success of the simulation has sparked a debate about the future of intelligence. Some believe this path could lead to a deeper understanding of neural structures that can be used to improve traditional artificial intelligence. More importantly, it raises difficult ethical and legal questions. If a human consciousness can be digitized, it is unclear whether the digital copy would possess the same rights as the original person. As technology moves from science fiction into the laboratory, society remains unprepared for the legal, religious, and moral consequences of a world where life can be copied and stored on a server.